Okay, so like this EQ implies, we're going to talk about reflections across the line here in orange. This line here, if you count, it has a slope of positive 1 over positive 1, and we would just say that it's y equals x, right? So that's exactly what we're going to talk about here in this video, is reflections across the line y equals x. Okay, and in the past videos, we were counting either vertical or horizontal lines. Here, we're going to count diagonals, right, to see what the pattern is. So very quickly, let's go ahead and count. So how far away, for example, is B, right? So 1, 2, 3, 4. So we're going to go 1, 2, 3, 4. Okay, so we know B is going to be here. We'll call that B2. Let's count A now. So 1, 2, 3, 4, 5. 5.5. Okay, so there's our half. 1, 2, 3, 4, 5. So we know A2 is going to be there. And C, well, we can just guesstimate. We know C is going to have to be 2 away from where B is at. Okay, so we see the symmetry there. Now let's look at the actual numerical pattern. So for A, we went from -4 by 7 to 7 by -4. Okay, for C, I know I'm going kind of out of order here, but it is what it is. For C, we went from -5 by 5. Then we went to 5 by -5. So you can already catch on what the pattern probably is. For B, -3 by 5, and we went to 5 by -3. Okay, so what exactly is the rule that we're following here, right? Well, we went from xy to what? Well, we obviously just flipped our y and x coordinates. They just changed spots. We're just going to say flip x and y. And in parentheses, we're going to put a little side note, places, so that we don't get confused and think we mean signs. We literally just traded places with x and y. Okay, so if we follow this simple rule, that's all it takes to reflect across the line y equals x. Okay, any questions over this? Come and see me. Goodbye.